Hello everyone, in this video we'll talk about cellular network, especially on how the internet is accessed in the cellular networks based on the evolution of cellular network architecture and standards. Alright, so first of all we'll list the components of the cellular network architectures. First of all we have cells, or in the term that we use in the Wi-Fi network is called BSS. But in this case we'll call it cell. So basically cell is the cover the area covered by the base station. Alright, so that's why there must be one base station in one cell, and then there are several mobile users that are attached to the base station within the cell, and then the area interface, basically the wireless link between the mobile users and the base station. Alright, so now we have several base stations. So let's say in one city, the telco operators may have more than, I don't know, thousands of base stations, and some base stations are connected to one mobile switching centers. This mobile switching center is like, I would say, a router, right? That is very important to connect between the wireless networks, the users that are using the mobile or air interface, with the rest of the internet or rest of the networks. It also manages the call setup and handles mobility. These two aspects will be discussed later in the mobility part. Alright, in the first hop is basically the air interface between the mobile terminal and the base station. There are actually many technologies, or let's say air interface technologies, but in this occasion we only talk about two technologies. The first one is combined FDMA and TDMA, and the second one is CDMA. So basically the FDMA and TDMA is the technologies that are used by the second generation GSM network. So basically as we know, the FDMA is, we divide a frequency spectrum into several frequency bands, and this is used to avoid the interference between adjacent cells, basically. So for example, now we have cells 1, 2, and 3, so we don't want that or 1, 2, 3, 4, 5. So let's say in the middle cell we assign frequency number 1, so we don't want to interfere with the 1, 2, 3, 4, the other 4 cells, neighboring cells. So we have to assign the 4 neighboring cells with 4 different frequencies, right? So they don't interfere with each other. But then maybe in the next cells, let's say the 6 cells, we can already reuse the frequency that is used by the first cell in this case, right? So basically the FDMA is to avoid frequency between neighboring cells, but then in principle the users within the same cell, they will use the same frequency band, right? So to differentiate the users in the same cell, they will be allocated with different time slots, or in this case we are using the TDMA, or time division multiple access. So to receive and to transmit data from mobile to base station, each user will have different time slots, right? To different let's say different time frame to send and to receive. While in the CDMA, we are not dividing the users and to transmit in different frequency or time slots. They can use all the time and frequency, but then the transmission will be differentiated by different codes. So basically the base station will assign each user with unique codes. This unique code will be, let's say, become like kind of cipher code for the data that is transmitted or received. So the receiver can only decode or recover the data if the unique code is matched. So that's the basic idea of this, but the technical details of the CDMA is a bit more complicated than FDMA and TDMA. Alright, so we move to the architecture in more than just, let's say, between the mobile terminals and the base stations. So we start from the second generation. or the voice network, because at that time we only have voice traffic for the second generation or GSM network. So basically, I think starting from the base station, we have the BTS, or stands for the base stations, base transceiver stations. That's the last mile for the user or the mobile subscribers. And then several base stations are connected to the BSC or base station controllers. And then several base station controllers or BSC are connected to the MSC or mobile switching center. And then these MSCs are connected to the gateway MSC. And then this gateway MSC is basically, it's just like every telco operators or cellular operators will have this gateway MSC to connect to the public telephone networks, or even, let's say, other cellular network from different operators. Okay, so I'm just going to make analogy with the network topology that we already studied until now. So I would say this, if we make the analogy with the Wi-Fi networks, let's say the BTS is like our wireless access points, and then several wireless access points can be connected to the switch. This BSC can be analogous with the switch, and then this BSC several switches can be connected to the router. The router is like it is just the internal routers in the private networks. And then to go to the public internet, we need to connect to the gateway routers. So that's just the analogy with the network that we have already studied. Okay, now we go to the 3G networks. In principle, if it just consider the voice traffic, all the components or all the entities are the same, but then we are now adding the data traffic to the in parallel with the voice traffic. So in this case, we add something called SGSN, or serving GPRS support node. So this is in the same level as the MSC, and then there is GGSN, or gateway GPRS support node, which is the gateway to the public internet network. And then the BSC, now the term BSC is changed into radio network controller, because in the BSC it only handles voice traffic, but now in the 3G it also handles the voice and data traffic. So this entity here, RNC, also has to it is also responsible to split the traffic, voice traffic and the data traffic. So it's just, yeah, because the function is different, that's why the term is also changed. Okay, now it's just to differentiate the parts in the topology or network architectures. So we have radio interface. Basically, mainly this is in the base stations to the user equipment or the mobile users. It is related with the technology, the access technology. So they are using WCDMA, and this is the first generation of 3G, and then the later generation of 3G uses HSPA. And then the radio access networks, this is from the base station up to the RNC, or it is also called UTRAN. And then from RNC to the gateway MSC or GGSN, it is called the core network. So basically, yeah, this is it's not related with the wireless or wireless link anymore. So it's totally wired networks. But before we go to the public internet network, so beyond this, it is called the public internet. Alright, now we come to the 4G or 4G LTE networks. Now we can compare the two between 3G and 4G LTE networks. The most important things, there are two differences, two important differences between 3G and 4G. Now in 4G, there is no more separation between voice and the data traffic, so everything is unified into one IP networks. Alright, so there is no separation between voice and data anymore. And also the core networks, becomes much simpler because there is no more SGSN, MSC, or even the RNC, right? So there is only MME and SSS, and those are not related directly to the data plane. It's just the control planes. Basically, it is for the mobility management function and location functions. Alright, so to send the data or to forward the data from the E node B or base station to the serving gateway, the 4G is using the tunneling. So this all IP core basically from the E node B to the serving gateway up to the public internet, right? And then this is done through the tunneling. Okay, and then there is no separation between voice and data. That's the most important difference between 3G and 4G. And this is just to summarize the 4G architectures. Basically, first we have the E node B. There are a lot of terms here, but don't worry. It's just basically functions in radio interfaces, RRM, radio resource management, mobility control, and so on, radio admission control, so on and so forth, and a lot of things on the physical and MAC layers. And then the MME is entity that is responsible for managing the mobility, handles the active and idle UE, user equipments, send the paging to the UE, and so on and so forth. And the serving gateway, it is almost similar to the SGSN. It's act as the mobile anchor. So it's like the anchor point for each user equipment, and the packet data gateway, it allocates the IP address for each of the user equipments, and also it responsible in packet filtering. So basically, it's like the gateway, the router gateway. That is, so before all the traffic enters the networks, let's say the corporate networks, it has to filter the traffics. Alright, so I think that's it for now. And this is also the last part of the wireless aspects. We'll continue with the mobility aspects in the next video. So see you again next time.